Hey everyone, good to see you. Well, not really, but so I thought we could go through some problems. How about this one? Secant x minus secant x sine squared x equals cosine x. Oh, by the way, these first few problems, these are all verifying. These are all verifying problems I want to do with you today. We've got 4 days worth of practice on solving. That should be enough. So instead, let's take a look at verifying. Okay, so how will you verify that this is equal to this? You can, of course, turn this into that. I'm going to be turning this into that. All right, so pause the video, give it a try. Let's see how it turns out for you. Hey everyone, did you start by factoring a secant out? Remember, secant divided by secant is 1, not 0. We took this secant out, so we have just the sine squared left here. Hey, what is 1 minus sine squared? Well, that's cosine squared. And secant is 1 over cosine. And so I guess I could take a cosine with a cosine and have cosine x, and I'm all done. All right, how about this one? Sine x tan x equals secant x minus cosine x. And I think that minus cosine x goes with this problem. Yeah, I think so. Okay, so what can you do here? You're going to work this side or you're going to work that side. I kind of want to work this side because this has 2 things and this only has 1. But, no, we could do the left. Maybe we should do both. So, how about sine x times sine x over cosine x? Oh, well, that's the same as sine squared x over cosine x. Hey, and sine squared is 1 minus cosine squared. And what happens if I split this fraction into 2 pieces? One of those pieces is 1 over cosine. Then we have that minus. And now we have cosine squared over cosine. And so what happens with this? Well, 1 over cosine is secant. And I cancel and have minus cosine. And I'm all done. Okay? Working the other side of the problem, I've got 1 over cosine minus cosine. I want to take 2 things and turn them into 1 thing. I better make a common denominator. So I multiply over here by cosine over cosine. 1 minus cosine squared. Well, I know that 1 minus cosine squared is sine squared over cosine x. So I could say, well, that could be written as sine x times sine x, and I could just put that cosine x under one of them. And so now I've got sine x times tangent x. And we're all done. Okay? Okay. How about this one? 1 minus cosine theta over sine theta equals cosecant theta minus cotangent theta. All right. And again, I kind of want to ask the question, which side do you want to work? Which side do you want to work? Well, we could work either. Let's start over here. Yeah, so many, by this point, many students are thinking, I should do 1 plus cosine, because Kukla showed me that the conjugate could be really useful. And if I FOIL on top, I've got 1 minus cosine squared, and on the bottom, I've got sine theta 1 plus cosine theta. Okay, 1 minus cosine squared, that's sine squared. Got that sine on the bottom, 1 plus cosine. Okay, well, I can cancel a sine. Now I have a sine theta over 1 plus cosine theta. But wait a minute. That's not helping me, because I can't split this into 2 fractions, which I'd really like to do. So yeah, conjugate, I don't want to do that here. I don't want to do that here. Instead, I would really much prefer to say, I think the easiest way to do this problem is to say, let's split this into two fractions. Because then I've got cosecant minus cotangent, and I'm done. Mr. Kuka, how am I supposed to know when? ... Well, your ellipsis is really good. Yeah, sometimes I want to multiply top and bottom by the conjugate, and other times I want to split this one fraction into two. And I don't necessarily know what's going to work and what's not, which is why we have that long list of strategies. And if you've misplaced your list of strategies, yeah, I would strongly recommend going to pay it a visit again, because you're going to need them. Now, when we did this with conjugate, it did bring us some places. In fact, I could have gotten here, but it just would have taken a lot more steps. And so, yeah, splitting that fraction up. What would make me to think about splitting that fraction up? Because when I look where I'm going, I see I got two terms. And so I want to split that up into two terms. Okay. How about this? Oh, did you want to do the? No. Okay. Sine t tan t plus cosine t cotangent t should turn out to be sine t plus cosine t. Okay. Verify. Go to it. I can't wait to see. You already know what you're supposed to get, so show me how to get there. Okay. Yep, I did. I started by rewriting tangent as sine over cosine and rewriting cotangent as cosine over sine. Cool. Well, let's do the flip and multiply now, both with this one and with this one. Then I have sine t times cosine t over sine t plus cosine t times sine t over cosine t, because I have to flip it. Cosines cancel, sines cancel, sine plus cosine, and I'm all done. Oh, that wasn't so bad. Some people want to make a common denominator here. Really? Cotangent t times tangent t, tangent t. Okay, so common denominator, cotangent t times tangent t. And on top, we've got cotangent t sine t plus cosine t tan t. Well, that doesn't look better to me, but they're cofunctions. Cotangent is 1 over tangent. Oh, well, so those can cancel. And so all I'm left with is this. Well, I know that cotangent is equal to cosine over sine. And tangent is equal to sine over cosine. And there we go, cosine t plus sine t. Done, done. So, lots of ways to do these problems, if you're comfortable with your strategies. Please be comfortable with your strategies and with your trig identities. Okay, how about this one? Cosine x over 1 minus sine x plus 1 minus sine x over cosine x should equal to secant x. I'm wondering if that's supposed to be a plus. Is that supposed to be a plus? Let's find out. Yeah, so what do you want to do? You know, some students say they would like to multiply top and bottom by conjugate. Other students say let's make a common denominator. I would probably try the conjugate first myself, but most students are going to make a common denominator. Okay, looks like I'm going to have cosine squared. Here I've got some foiling to do. I have 1 minus 2 sine x plus sine squared x. And all of that is over this common denominator we made, cosine x, 1 minus sine x. Okay, resist the temptation to distribute here is what I've been saying for the last few videos. Ooh, cosine squared plus sine squared is 1. 1 plus 1 is 2 minus 2 sine x over cosine x, 1 minus sine x. Well, we're supposed to end up with 2 secant x. I see a cosine in the bottom, that's good. I see a 2. I see another 2. Ooh, I could factor out that 2. And I'd have 1 minus sine x on top, and cosine x, 1 minus sine x on the bottom. 2 over cosine is 2 secant x. Done. All right. How about this one? Oh, this is a great problem. Secant squared x cosecant squared x equals secant squared x plus cosecant squared x. So this times this should equal this plus this. Oh, that's very interesting. Yeah, so give it a try. Oh, by the way, are you going to work this side or this side? Does it? I don't know. I can't wait to see. Hi, welcome back, everyone. So secant squared, isn't that 1 over cosine squared? Times cosecant squared is 1 over sine squared. Is that helping me at all? No. Well, so here's the thing. I've got these 2 terms over here, and I've only got 1 here. Here, I might consider making a common denominator to take these 2 and bring it into 1. But here, what's to be done? Well, how about this? Cosine squared is 1 minus sine squared times sine squared on the bottom. No, that's going to have me being sine to the 4th. I don't really want that. And if I turn this into 1 minus cosine squared, is that helping? Well, I'm supposed to multiply them. 1 minus sine squared minus cosine squared. Minus times minus is plus, plus sine squared cosine squared. And a 1 on top. Okay, well, what can we do? Well, here on the bottom, I see sine squared and cosine squared. If I pull that negative out, this problem is now going to look like 1 minus sine squared plus cosine squared. And then there was plus sine squared cosine squared. Okay, so, and remember, all of this is happening in the denominator. Well, sine squared plus cosine squared is 1. 1 minus 1. Oh, all that stuff goes away. And so now I'm in the place where I have 1 over sine squared times cosine squared. And if I flip, we've got cosecant squared x times secant squared x. And that's what I'm supposed to have, so I'm done. Wow, okay, that was very labor intensive. I wonder if there's something I could do on this side. So, it's going to be 1 over cosine squared plus 1 over sine squared. And when I have 2 things and I want to turn it into 1 thing, I make a common denominator. So I multiply by sine squared here, sine squared, and here by cosine squared over cosine squared. Okay, so that's going to be sine squared plus cosine squared on top, and on the bottom, sine squared times cosine squared. Well, we know that's going to be 1. Sine squared plus cosine squared is 1. And so look what I've got. I've got 1 over sine squared times 1 over cosine squared. And so I'm done. Secant squared x times cosecant squared x. And done. Okay. How about this one? Secant x plus 1 over tangent x. Should equal tangent x over secant x minus 1. Okay. So I think what I want to do, just because we haven't practiced this enough recently, is I want to use the conjugate here. Secant x minus 1, no, plus 1. Okay. So I'm resisting the temptation to distribute. And on the bottom, I'm foiling. And when I foil, I get a difference of squares. Secant squared x minus 1. Well, what is secant squared x minus 1? It is one of our Pythagorean identities. What's it equal to? Well, secant squared x minus 1 is tangent squared x. So I can cancel those. So where am I now? I'm now at secant x plus 1 on top and tangent x. Oh, well, that's, yay! I'm done. See, conjugate can be really helpful here. There are some people who will turn all of these into sines and cosines. That's going to make this problem actually a lot harder. So I would recommend conjugate here. Use the conjugate. What if I wanted to do conjugate on the left-hand side? So I've got secant x plus 1 over tangent x, and people saying, hey, what about secant x minus 1? Secant x minus 1. Okay. Well, I'm going to FOIL on top. That's going to give me secant squared x minus 1. On the bottom, I have tan x times secant x minus 1, and I'm still not giving in to the temptation, because secant squared minus 1 is tangent squared. On the bottom, we have that tangent that we can multiply secant x minus 1 with, but we don't need to because those are going to cancel. And we're going to have tangent over secant minus 1, which is exactly what we wanted it to be. So please think about using the conjugate. If you want another nice problem like that to look at, this is another nice problem like that. Cosecant x minus 1 over cotangent x equals cotangent x over cosecant x plus 1. Yeah, this works just like the last problem. You should be able to use conjugate over here. You should be able to use conjugate over here. And if you were really looking to make life hard on yourself, you could turn all of these into sines and cosines. I mean, it's just though, when you turn these into sines and cosines and do a bunch of work, you've still got sines and cosines. So even when you are getting someplace, you're still going to have to take time to reconvert back into cotangents and cosecants. And I don't recommend that. All right. How about this one? This is a little more thrilling. Sine to the fourth minus cosine to the fourth. And that should be 1 minus 2 cosine squared t. All right. I've seen this problem done a couple of ways. The first way I've seen this problem done is people say, oh, that's a difference of squares. And it is. And they write sine squared plus cosine squared, sine squared minus cosine squared. And then they say, oh, look, that's 1. So now they have sine squared minus cosine squared. And these people look here, and then they look over here, and they say, hey, look, this has a siney thing, and this doesn't have any siney thing. So I'm looking for a way to get rid of sine squared and replace it with some cosiney stuff. And luckily, I know sine squared is 1 minus cosine squared. So when I combine like terms, I'm done. Okay? But this required me to see that difference of squares. A lot of people don't see that difference of squares. Some people see that sine to the fourth could be rewritten as sine squared times sine squared minus cosine to the fourth. So this is 1 minus cosine squared, and this is 1 minus cosine squared minus cosine to the fourth. If I do my foiling here, 1 minus 2 cosine squared plus cosine to the fourth minus cosine to the fourth. Well, look, those cancel. I'm left with just these. And that's what we were trying to make. And we're done. So lots of options here. Be comfortable with as many of them as you can. What this one? Cosine squared x minus sine squared x over 1 minus tangent squared x. And that's supposed to equal cosine squared x. Isn't that interesting? Yes, you could split this into two fractions, but since I only see one over here, I'm reluctant to do that. I do not know what that is. I know what 1 plus tangent squared is, not 1 minus tangent squared. Ooh, and suddenly Kukla discovers why it is that this has a star next to it. It looked so friendly. That's because I thought that was a plus. Oh, if only these were pluses. Yeah, but they're not. But maybe if they were pluses, this would be 1, and this would be, if that was a plus, this would be secant squared. 1 over secant squared is cosine squared. Yeah, but you can't do a couple of wrong things to generate the right answer. We're going to be looking for that stuff. So what do you say? Well, here's what I say. I say over here, I just eat cosine stuff. So I'm interested in getting rid of some of these things and replacing them with cosine things. All right, so up top, how about we start off with that? I don't know. Am I going sine squared, cosine squared on that? Maybe. And then I guess I should probably make a common denominator. So what am I looking at? Well, look at that top. That's cosine squared minus sine squared. Okay. Oh. You know, this is something I haven't talked about in the videos. But it sometimes happens where you're like going and going and going. And then you say, oh, look, there it is. And really what you're supposed to say is, I'm trying to turn this into that. Right. Okay. So let's see what I can do here. On top, we got rid of the sine squared and replaced it with this stuff. So I'm going to have negative 1 plus 2 cosine squared over cosine 2 cosine squared minus 1. And on the bottom, we've got that common denominator, cosine squared, and here we have cosine squared minus sine squared. Wow. Well, yeah. So, well, remember that this was originally cosine squared minus sine squared. I think I'm going to go back to that. And the reason being is because I see this cosine squared minus sine squared. But I need to do flip and multiply. So let's try that. So we've got cosine squared minus sine squared on top times flip cosine squared over cosine squared minus sine squared. Oh, look, these are the same, and we are left with cosine squared. Yeah, I don't know that there's anything that hard on our assessment, but maybe things will feel that hard on the assessment. Okay, well, I I think that's all we're going to do with this review. Let us know if you need some more problems, and we can certainly come up with them. Yeah, glad to help. And that was assignment 40. Assignment 40 in class. All right.